Okay, so here are just a few examples from section 2-3 we did in class. Again, in case you're absent or in case you need a refresher on something and want to go through the whole video of watching me go through it before. So we did these in class where we converted them to if-then statements in the converse, inverse, and contrapositive. The reason we did that is this. Um, Whenever you have the related statements, the conditional, converse, inverse, contrapositive. The conditional and the converse and the inverse and contrapositive are actually more related. Um, a conditional and contrapositive are equivalent. Converse and inverse are equivalent. So they work out that way. So let's go back here. Okay, I'm going to do number 4b because 4a is true, so it doesn't matter. But 4b, a hamster is a rodent. Okay, I'm going to say if it is a hamster, then it is a rodent. That's my initial statement. That'll be the PQ. So the conditional. If it is a hamster, then it is a rodent. The converse would be switched. It would be if it is a rodent, then it is a hamster. The inverse goes back to the conditional and says if it is not a hamster, I just said hamster, then it is not a rodent. And the contrapositive says if it is not a rodent, then it is not a hamster. Because what that does is that switches, again, conditional, just an if-then statement, you make it once and you go with it. Converse switches the order. Inverse makes them both nots. Contrapositive switches the order and makes it both nots. Now here's the deal. I'm going to put this in green, the stuff that's true, and the stuff that's not true, I'll put it in red. So this is true. If you're a hamster, you're a rodent. A rodent's anything like a mouse, any kind of ground, things like a chipmunk, whatever. So it's a rodent or a rat. A rat's also a rodent. Now, here's the deal. If it's a rodent, then it has to be a hamster. That's false. Because you could be, if you're a rodent, you could be a mouse. A mouse is a type of rodent. It's definitely not a hamster. So that's false. Okay. Inverse. If it's not a hamster, then it's not a rodent. Again, that's false. A mouse is not a hamster, but it definitely is a rodent. So false. And then if it is not a rodent, it's not a hamster. Now that is true. Because if you're not a rodent, that means you can't be a hamster, a mouse, whatever it is that fits in that thing. So this has to be true because I know I'm not a rodent, so I know I can't be a hamster since a hamster is a rodent. Okay, so you'll notice the conditional and the contrapositive of the same truth. They call it validity, it's the fancy word for it. And the converse and the inverse of the same validity. That always works out that way. So again, if-then statements, related conditionals, logically equivalent. A conditional that's contrapositive are logically equivalent. That means they have the same truth. And the converse and the inverse are logically equivalent. So in class, we went through and did some more of these. Hypothesis and conclusion. Hypothesis, I'll just highlight the hypothesis and let's say green. Hypothesis, two angles are adjacent, then have a common side. That's the conclusion. If you lead, that's the hypothesis, then I will follow conclusion. Okay. Going through now, looking for false statements. If a number, like for instance 35, doesn't work, okay. If a number is odd, then it's divisible by 5. Well, here we go. 7 is odd, but not divisible by 35 or by 5. So that's an example of something that's false. We would say false, 7 is odd, but is not divisible by 5. Again, this is making contrapositive, inverse, converse like we did for example 4, so I'm not going to waste time with this. The last thing I do want to talk about though, is if you missed this, is something called the biconditional statement, because we actually use this quite a bit later on. We start talking about things called theorems. And what the biconditional is a statement where both the conditional and the converse is true, which means if the conditional and converse is true, all 4 of these guys are true, because that would mean that we go back to this statement. That means conditional is true, which means contrapositive is true. Converse is true, which means the inverse is true. So all four of them are true. So an example of that is something like, if I go back to the example here. Okay, two angles have the same measure if they are congruent. If two angles have the same measure, then they're congruent. True. If two angles are congruent, they have the same measure. True. If two angles are not do not have the same measure, they're not congruent. True. If two angles are not congruent, then they do not have the same measure. True. All four of those statements, the conditional, the converse, inverse, contrapositive, all four of those are true. That means we can turn it into what we call a biconditional statement. And there's their example here. Amy is elected by the district coaches. Amy makes the All-Star team. If Amy is elected by the district coaches, then she makes the All-Star team. If she made the All-Star team, she was elected by the district coaches. That's true both ways. So we make this stronger statement called the biconditional. And the way it works then is it's called an if or only if statement, or if and only if statement. So Amy makes the district team if and only if, what was that statement? I'm sorry, she makes the All-Star team if and only if she is elected by the district coaches. Okay. And this is a very strong statement because this is saying something like, no matter what, I mean, this is the only way this can happen. Amy only makes it if she's selected by the district coaches. And if she's just selected by the district coaches, we know she's guaranteed to have made it. A little shorthand notation for math teachers is this. They don't like writing if and only if for some reason. So there's IFF, like an if. That means if and only if. Okay. So we'll talk about that. And again, this will pop up in some of our theorems later on. So for instance, an angle is right angle if and only if it measures 90 degrees. Okay, that's true. So here's a conditional. If an angle measures 90, then it's a right angle. If it is a right angle, then the angle measures 90. That's definitely true. So it means this is a true biconditional statement. However, this is not part B is x is greater than -2 if and only if it is positive. Well, if it's here's the first one. If it's positive, it's bigger than -2. That's true because positive numbers are bigger than -2. If it is bigger than -2, then it's positive. That's false because -1's bigger than -2 and -1 isn't positive. So what this means is you cannot make this an if and only if statement for B. It has to be split up and discussed separately. And then in class we went through and turned these guys, into conditional and converses and determine if they were true or false or not. But again, you'll see some of these examples as we move on through some of our other examples in the book and we talk about some of our theorems.